Welcome to the Explainer. Today, we are diving deep into the magic of real-time data streaming. You ever wonder how your bank can flag a weird transaction literally seconds after you swipe your card? Or how a ride-sharing app knows the exact price to charge you right at that moment? Well, the answer is this constant, lightning-fast flow of data getting processed in milliseconds. So let's break down exactly how it all works. In this quote, it just nails the whole reason we're talking about this. Yesterday's reports are ancient history. Trying to run a business on that is like driving down the highway, but you're only allowed to look in the rearview mirror. You only see the problems way after you've passed them. To win today, you have to be looking at the road ahead, and that is exactly what real-time streaming lets you do. All right, so let's jump into our first big idea, this incredible need for now insights. Why is waiting for tomorrow's data just not going to cut it anymore? Well, because in today's world, being able to react instantly isn't just a nice little advantage, it's pretty much a requirement for survival. And the engine that makes all this possible is real-time analytics. Now, this isn't just about doing the same old stuff but faster, no. It's a completely different way of thinking. We're moving away from looking at a static pile of data to ask, so what happened yesterday? And instead, we're plugging directly into a live river of data to ask, what is happening this very second? This means we can predict and even prevent problems, not just write a report about them after the damage is done. And believe me, this isn't some far-off theoretical thing. It's happening all around you, right now. It's your bank's fraud detection saving your bacon. It's the dynamic pricing that sets the cost of your flight. It's that e-commerce site suggesting a product based on the very last thing you clicked on. Every single one of these moments depends on processing data, not in hours, but in milliseconds. It is the invisible engine of our modern digital lives. Okay, so to really understand why this is such a massive deal, we've got to look at the old way versus the new way. We are talking about a fundamental shift, moving away from collecting data in these slow, clunky batches to processing it as a continuous live stream. Let's really dig into what that means. So, over on the left, you've got the old school way, batch processing. Think of it like a slow, steady tortoise. You collect data all day, you stuff it in a big box, and you process it overnight. You get your report hours, maybe even a day later. But on the right, you've got streaming. That's the lightning bolt. It processes every single event, every piece of data, the very instant it happens. We're talking milliseconds. And this isn't just about being faster. It's the difference between finding out your house was robbed yesterday and getting an alert the second someone touches the doorknob. So how do we actually build these incredibly fast systems? Well, it's not just one magic tool. It's more like a team of specialized platforms all working together. You can think of them as the key players in a real-time data orchestra, where each one has a really critical part to play. Let's get to know the stars of the show. First up, we've got Apache Kafka. The absolute best way to think about Kafka is as the central post office for all your data. Its job isn't to read the mail, but to reliably sort and hold it, making sure that not a single message gets lost, even when millions of them are flooding in every second. It's the rock-solid foundation, the super reliable backbone of the entire system. Next in the lineup is Spark streaming. So if Kafka is the post office, think of Spark as the super efficient sorting room. It takes that fast-flowing river of data and cleverly chops it up into these tiny, manageable chunks called microbatches. Then it processes these chunks at incredible speed. This makes it amazing for tasks like ETL, that's extract, transform, and load, which is just a fancy way of saying cleaning, reshaping, and getting data ready for a database or a machine learning model. And then you've got Apache Flink. This is our true real-time detective. So if Spark is processing data in little photo albums, those microbatches, Flink is watching the live video feed. It looks at every single event, one by one, the instant it happens. This gives it crazy low latency, making it perfect for spotting complex patterns in the moment, like a potentially fraudulent transaction or doing calculations over what we call sliding time windows, like what's the average temperature over the last 60 seconds, updated every single second. And finally, there's AWS Kinesis. For anyone building on Amazon Web Services, Kinesis is basically the easy button for data streaming. It's a fully managed service, which means you don't have to worry about setting up servers or dealing with all that complex infrastructure. AWS handles all that heavy lifting for you, so your team can just focus on writing the code that actually analyzes the data. It's designed to just plug and play with the entire AWS world. Okay, so here's maybe the most important thing to get. These tools aren't really competitors, they're collaborators. You almost never just pick one. Instead, you assemble them into what we call a data pipeline, a sort of digital assembly line for information. Each tool is a different station on that line, doing its unique job before passing the data on to the next. This little table really breaks it down. Under processing, you can see Kafka is just the messenger, right? Spark uses those microbatches, and Flink does true one-by-one streaming. This has a huge impact on latency, where Flink is the undeniable winner with the lowest delay. But now, look at the stateful row. This is Flink's superpower. Stateful means it can remember what happened before. So if it sees a small transaction from you in Paris, and then 1 second later, another one in Tokyo, it remembers the first one and can instantly flag the second one as impossible. That's a total game changer for complex analysis. So let's follow the data's journey. Step 1, an event happens. A user clicks, a sensor pings, a purchase is made. Step 2, that event is immediately fired off to Kafka, our central hub. Step 3, an engine like Flink instantly reads that event, analyzes it, maybe adds more context to it. And step 4, the output, the actual insight, is sent to its final destination, maybe a live dashboard or an API or an alert right to your phone. From event to insight, the whole thing happens in milliseconds. It's just a continuous, intelligent flow. All right, we've seen the tools, we've seen the blueprint. Now let's see this stuff in action. We're going to check out a couple of really high-stakes examples where this tech is making a massive difference every single second of every day. Look at this number, 500 milliseconds. That is less than half a second. It's faster than you can blink. This is the entire window of time a bank has to analyze your credit card swipe, check it against your entire history, and decide if it's fraud, all before the payment terminal says, approved. In this game, there is absolutely zero room for delay. And here is what's happening in that split-second decision. 1, you make a purchase. 2, the transaction flies into Kafka. 3, Flink instantly grabs it, enriches it with other data like where you usually shop. 4, it feeds all that to a machine learning model which spits out a fraud risk score. 5, if that score is high, boom, an alert is triggered and the transaction is blocked. All 5 of those steps, done, in less time than it takes you to blink. This is where Flink's low latency and stateful processing really shines. Another huge area is the Internet of Things, or IoT. Just imagine millions of sensors on wind turbines, factory machines, you name it, all streaming data constantly. As you see here, that data flows into the pipeline. Flink can then do these complex, time-based calculations like, hey, what's the average vibration on this engine over the last 5 minutes? Is it trending up? The results get stored and then visualized on live dashboards. This lets engineers spot a part that's about to fail and schedule maintenance before it causes a catastrophic shutdown. So, we've seen the tech, we've seen the applications. Let's zoom out for a second. What is the big takeaway here? What does this whole shift to real time really mean for you? Let's just boil it all down. First and most important, real-time processing isn't a luxury anymore. It's the price of admission if you want to compete. Second, remember our analogies? Kafka is the post office. Its job is to move the data reliably. Spark and Flink, they're the brains of the operation. Their job is to process that data intelligently. And then tools like Kinesis just make it way easier to build and scale all of this in the cloud. Honestly, for anyone working in tech today, getting a handle on this flow is absolutely essential. And that brings us to the final question I want to leave you with. Just look at the data that's all around you, at your job, in the apps you use every day, and ask yourself this. Is it telling you a story about yesterday, or is it helping you make a decision right now? Because that shift, from the past to the present, that's where the future is being built. Thanks for joining me for this explainer.